Welcome to the lair of the Batty Boffin.
Hi there Batty fans, time for another bit of speed, distance and time with the Batty Boffin. Today we're looking particularly at acceleration and velocity. Now in earlier videos we looked at the concept of speed as being the change in your place divided by the amount of time it took you to do that change. So in other words, the distance you travelled divided by the time it took you to do that travelling. Speed equals distance divided by time, and we use that formula triangle. We also introduced the concept of acceleration, which is not the change in your place divided by the time it took you to do the change, it's the change in your speed divided by the time it took you to do that change. Okay, so change in velocity or change in speed divided by time. Okay, now sometimes in maths and physics we use this symbol delta. Just looks like an equilateral triangle. Sometimes you see it with kind of one side coloured in a bit more. Delta, and we use that to mean the change in. Okay, so delta V would be change in velocity, delta S could be change in speed, delta L could be a change in length, that kind of thing in there. Okay, so delta just means the change in something. We use that when you've got things like metals expanding when you heat them. Delta L is the change in length. So using that, particularly we're going to use delta V in this particular case, do you think you could have a go at working out what the formula triangle would be for acceleration? Speed is change in distance over time. We usually just say d for distance. Acceleration is the change in your velocity over time. So pause the video and see if you can write out the formula triangle, please. Right, so here's the formula you should have for that. Acceleration is change in velocity, delta V, over time. You could have put delta S if you'd want to do for delta speed, I don't mind. Okay, so acceleration is change in velocity over time. Now I've also put another one at the bottom there that you might have seen if you're studying this course from a point of view of kind of physics. Mathsy kind of things tend to use that way, physicsy kind of things tend to use that way. It's exactly the same maths, just a different way of stating it. In physics we get these Newton's laws of motion quite a bit, and they use things like this. Here we have got U and V for the initial velocity and the final velocity. A, of course, is acceleration and T is time. And we're going to do some calculations using both ways. You'll see it's exactly the same math, just different ways of writing it out. So, to do this, we are going to have you stepping off the top of a tall building and being caught by Superman. So, I'm just going to draw a picture. I'm going to kind of speed it up so hopefully it looks a little bit cool. And you'll see, of course, why I teach maths and physics, not art. I'm not the greatest drawer, but here we go. Right, this is you just having stepped off the top of a tall building. I'm not quite sure why. You don't look very happy about it. And in best cartoon physics style, for an instant, you are not falling. Of course, in cartoons, this instant can last for as long as it takes for you to realise that there isn't actually any ground underneath you, at which point you start falling. But here, so your initial velocity is 0 meters per second. Downwards. Of course, if it's a velocity, we do have to specify a direction, because directions actually matter for velocity. Fairly obviously, it's downwards. Okay? So, that's your initial velocity. The time taken, how long should we have you falling for? Let's have 5 seconds, shall we? So, T equals 5 seconds. And we need an acceleration. Now, your acceleration in this case is provided by gravity. So your acceleration is, we give it the letter G when we're talking about the acceleration due to gravity, and it has a standard value. It's about 9.81, but often for these calculations we round it off to 10. So 10, and the units for acceleration, meters per second squared. Meters per second squared, that's meters per second, okay? Now this is a fairly easy calculation. You may be able to see the answer, but I will just go through it anyway. Okay, so your initial velocity is 0, your acceleration is 10 meters per second squared, and you're falling for 5 seconds before Superman catches you. Now, we're ignoring air resistance on this here, so there's no forces acting on you to slow you down at all, you're just plummeting downwards. So we're going to work it out, first of all with this, and secondly with this, and then after the break you're going to have a go at doing some yourself. So let's do that one first up there. Okay, delta V is the change in velocity. Now, we know the initial velocity, so if we know the change, we can work out the final one, and it's pretty easy, really. Change in velocity is A times T. Okay, so delta V equals A times T, which in our case, pretty easily, is 10 times 5, which is 50. Your change in velocity is 50. And since your initial velocity was 0, it means your final velocity, therefore, must be 50 metres per second. Okay, it's pretty easy, isn't it, there? Now, that's with the triangle. We can do exactly the same calculation using this one here. And you can use whichever you prefer of these. You can use that method or that method. I'll always do both, I think, just so that you can see them worked on here. So using the formula down here, V, our final velocity, equals U, our initial velocity, which is 0, plus A, our acceleration, which is 10, times by T, our time, which is 5. And pretty obviously, again, that lot comes to 50. So your final velocity is 50 metres per second. Now, these are ones where the velocity is moving downwards and gravity is also in a downwards direction. Accelerations also have directions in them. But what happens if you were moving upwards, like if you got, a cannon or something firing upwards, or, a rocket, one of those stomp rockets firing upwards, in which case your initial velocity would be upwards, but the acceleration due to gravity would be downwards. Well, of course, we know what happens. It slows it down, doesn't it? Here, gravity is acting on you to speed you up. But if it was something like a stomp rocket, gravity would be working to slow it down. That's because here we've got your velocity and your acceleration working in the same direction. But in the stomp rocket, your velocity would be upwards and acceleration would be downwards. So one would be negative of the other. So after the break, we're going to do some like that. I'll see you in a minute. Okay, here's one for you. So what we've got, there's you there, and you've got a ball in your hand, and you throw it upwards, okay? You throw it up with an initial velocity of 45 metres per second. And I want to know how long it will be until the ball comes to a halt. Now, again, ignoring all air resistance and things, we have got our acceleration as we had before. Acceleration is gravity, which is 10 metres per second squared. But gravity is working downwards and your velocity is upwards. So we're going to count gravity as being negative 10. And that's right, because it's slowing it down. A negative acceleration means it's slowing down. Okay, we don't tend to talk about a deceleration. We just say everything's called an acceleration because it's changing the velocity, but a negative acceleration is actually slowing things down. So since you've got an initial velocity and your acceleration is negative, that velocity will at some point reach 0. Of course, that's when the ball gets to the top and then it starts coming down again. So we've got our initial velocity, we've got our acceleration. We know the final velocity as well, because of course the final velocity needs to be 0. So in terms of the u and the v, our initial velocity is 45 metres per second. Our final velocity is going to be 0 metres per second. And if we're doing it in forms of here, our delta v, our change in velocity, is from 45 down to 0, obviously 45. Okay, so either by putting things into that formula triangle using the delta v, or by putting the v and the u into here and the a, and you need to find the t, then you can find it. By the way, if you're not happy with rearranging those equations, check out some of the Batty Boffin Maths videos where we do rearranging formulas. Okay, so time for you to pause the video and have a go at that, please. Right, I'm going to do it both ways. I'm going to do it with the formula triangle and with the formula up there. So first of all, I think we'll do the formula triangle. We've got delta V and we've got A and we want T. We want to know how long it is. So T is delta V over A. T equals delta V over A. Delta V, the change in velocity, the change in speed. The change in speed is 45. And A is 10. And that equals 4.5 seconds. Okay? 4.5 seconds. Easy peasy. And then I'm going to do it up here. I think I'll do it in a different colour. So I'm going to fill in the numbers and then we're going to wiggle it around until it says T equals. So V is 0. U is 45, its initial speed, initial velocity, plus A, which is negative 10, times T. Okay? Right. Remembering what we do when we unpack these, start from the outside and work your way in. Like a pass the parcel, you have to take off the outer layers before you get to the middle. The T is the prize in the middle of the pass the parcel, and it's got layers around it of this times by 10, and then it's got the add 45 on the outside. So I'm going to get rid of that 45 first by subtracting it from each side. So that will give me, I really could do with some space below this, couldn't I? Excuse me a minute. Okay, I'm going to subtract 45 from each side, and that'll give me negative 45 equals negative 10t. Then I'm going to get rid of this negative 10 that I don't want, so I'm going to do a divide by negative 10 on both sides, which is going to give me a negative 45 divided by negative 10 equals t. Good, I've got an equals t, that's what I wanted. Negative 45 over negative 10 is 4. Need to get some new pens, don't I? Oh. 4.5, and that's seconds again. So whichever way you did it, you should end up with 4.5. There, hope you got that. I'll see you next time, Batty fans.
Mwahaha!